Hello gals and guys, Mr. Ambrose here with another video on trigonometry. I first just wanted to begin by wishing those who are celebrating a happy Passover. And for those of you who may be celebrating other holidays this week, whatever they may be, happy Easter or whatever, I just wish that you guys are able to enjoy some time with your family. Today's video is going to continue looking at trig graphs. I hope that Monday's video on the sine graph helped you understand exactly how to graph those. And a reminder that the Tuesday sine graph homework assignment is due by Wednesday at 11:59 p.m. And this is going to count as a homework grade. But as I've done all year long, I will grade it based upon completion, not based upon accuracy. So please have it completed and submitted by this time. The other assignment for this week is going to be for Thursday and Friday, and it's going to entail a trig quiz. So I am sorry about this, but perhaps a silver lining to this is that this trig quiz will not be due until next week on Wednesday at 11:59 p.m. So hopefully this should give you enough time to complete this particular assignment. All right, so for today, we're going to be looking at the graph of the cosine function. If you want to, there is a PDF file on Classroom that you can print out if you want to take notes as I go through this particular lesson. The other thing I'll make mention is that the cosine graph looks very similar and behaves very similarly to the sine graph. So I'm going to develop exactly what the cosine graph looks like in the same manner as what I did for the sine graph. So what you'll perhaps notice here is that I have a table from which that I'm going to get the x and y coordinates from my cosine graph. The cosine function, the angles that we put in here, the x values, are also going to be in radian measure. So I've already gone through the process of taking my degree measure, multiplying each by pi over 180 to get the corresponding radian measure. And I've drawn out my unit circle, and I'm going to use the unit circle to get what is the cosine of the different angles. So those would be our y coordinates to our cosine function graph. So remember that when we go to our unit circle at any angle, the x coordinate is the cosine of that respective angle. So I'm going to start now by at 0 degrees and getting the cosine of each value. So at 0 degrees, the x coordinate here is 1. So that means the cosine of 0 is 1. At 90 degrees, the x coordinate there is 0. So the cosine of 90 is 0. At 180 degrees, the x coordinate there is negative 1. So the cosine of 180 is negative 1. At 270 degrees, the x coordinate there is 0. So the cosine of 270 is 0. And at 360 degrees, the x coordinate here is 1. So the cosine of 360 is 1. So these are our y coordinates. These are all our coordinates. And so now I'll use these y coordinates and the x coordinates to plot out our graph. As I did with the sine graph, the cosine graph ranges from negative 1 to 1. So I'll scale the y-axis accordingly. And the angles for cosine are going to be the same angles that I used to graph sine. So I'll just label those accordingly on my x-axis. And then from here, I will now plot my points. So at 0 radians, the y-coordinate there to our cosine graph is 1. At pi over 2 radians, the y-coordinate there is 0. At pi radians, the y-coordinate there is negative 1. And at 3 pi over 2 radians, the y-coordinate there is 0. And then finally, at 2 pi radians, the y-coordinate there is 1. And so now I have these points. And because we're getting all these points off of the unit circle, just like with the sine function, when you go to draw your graph, do your best job to try to draw it as a smooth curve because, it behaves, like I said, the cosine graph behaves exactly like the sine function. All right, so now that we have our cosine graph down, let's see what happens perhaps to our graph if we were to continue to rotate around our unit circle. The one thing I'll say is that just like with our sine function, right, if we continue to rotate around a unit circle after 360 degrees, while the angles perhaps will increase in size, the x-coordinates are just going to repeat over and over and over again. So I claim that as we continue to go around our unit circle and get more points, the cosine graph is just going to continue to repeat itself over and over and over again. So here's a picture of your cosine graph beyond just 2 pi. And hopefully you see here that the cosine graph just repeats over and over and over again. And this actually also occurs if we go out to the left as well. Our cosine graph just repeats continually, just like our sine function graph. And so just like with our sine function graph, the cosine graph that we drew was one full cycle of our cosine function's graph. And because the cosine graph repeats itself over and over and over again, we say that the cosine graph is periodic. And then one full cycle of any cosine function is also called the period, just like with our sine function graph. And just like with the sine function graph, the period of the cosine function graph is also just 2 pi. Some other similarities with our cosine graph and our sine graph: the domain of our cosine graph. Again, this graph is going all the way out to the right and all the way out to the left. So the domain of our cosine function graph is from negative infinity to infinity. And also, in a similar manner to our sine function graph, the range of our cosine function graph, when we look at this, the lowest y value is at -1, the highest y value is 1, and so the range of our cosine function graph is from -1 to 1. Now, we are going to transform the cosine graph around just like we did with sine, and the same rules are all going to apply. The key difference is that the key points for our cosine graph are going to be, well, they're going to be the same numbers, they're just going to be in a different order. The y-coordinates for cosine starts at 1, goes down to 0, then to -1, then to 0 and 1. Sine's key points were the same numbers, but in a different order. So just keep that in mind when you go to graph your cosine graph versus your sine graph. But all the other things that we saw with the sine graph are going to be the same as what we see with the cosine graph, meaning the number in front of our cosine graph is our amplitude. The absolute value, that I should say, is the amplitude. The number in front of our x is our frequency. And then we can use that to help find the period of any other cosine graph by taking 2 pi and dividing that by our frequency. And to break up our x-axis, we can take that period and just divide it by 4. And because these things are all the same, there's an acronym that I'll start to use to help me graph any cosine graph or any sine graph. And that's this acronym FPI, which stands for these 4 things. And so going forward, you'll see me use this acronym to help plot out any particular graph. So let's see this in action. So example 1, we want to graph one full cycle of the cosine graph with equation 3 cosine 1/2 x on the axes provided. So I'm going to start with my acronym FPI, and the A in FPI stands for my amplitude, which in this case is 3. And just like with the sine graph, I'm going to take my key points from my cosine graph, which are 1, 0, -1, 0, and 1. I'm going to multiply each one of them by my amplitude to get my y-coordinates for this graph here. So when I multiply 3 in, I'll get 3, 0, -3, 0, and 3. And remember, this is going to help me plot my y-coordinates for this function's graph. And in particular, we can maybe perhaps scale the y-axis accordingly, and I'll do that now. All right, next is the frequency, and I'll just label it as f, and that is the number being multiplied to our x, which is 1/2. Then in fpi, the next thing is the period, and I'll just label that as p, and the period of the cosine graph can always be found by taking 2 pi and dividing that by our frequency, which in this case is 1/2, and 2 pi divided by 1/2 ends up being 4 pi. You can do this on your calculator. You can perhaps just take 2, divide it by 1/2 to get 4, and then just carry the pi over. So our period of this graph is 4 pi, and the interval that we'll use to break up the x-axis for this graph will be our period of 4 pi, and divide that by 4. So we're going to break up the x-axis by pi radians, right? This tells us how to break up our x-axis. And so I'll do that now. I'm going to use the same every 2 markers to mark off each of my angles on the x-axis. So since our interval is pi, over here I'm going to label this as just being pi, and then pi radians from there. The next marker I'll mark as 2 pi, and then pi radians from there. This will be 3 pi, and then pi radians from there. This will be 4 pi. And now that I have my y and x axes properly scaled out, we can now just plot our points. At the very first angle here, the y coordinate there will be 3. At the next angle of pi, my y coordinate will be 0. At the next angle of 2 pi, my y coordinate there will be -3. At the next angle of 3 pi, my y coordinate there will be 0. And at my next x coordinate of 4 pi, my y value there should be 3. And then now that I have my points plotted, I will do my very best to try to draw out a nice smooth curve of this graph. And there is the graph to this particular cosine function. All right, so now we'll look at one other example, and we'll see just a couple other things that may happen here that can happen to the cosine graph, but can also happen to your sine graph. So here we're going to want to graph one full cycle of this particular equation. So I'll start off with my half pi and my a. Now, when I go to do my half pi here, whatever the number is here, I'm going to use that number. But if a question asks me for what is the amplitude of this particular graph, the amplitude of this graph is going to be +4, because the amplitude will always tell you how you go from the middle of your graph to either the highest or the lowest point. But to properly get my y coordinates, I'm going to use the negative here. I'm going to carry that through to get the y coordinates to my cosine function's graph. So I put in my y coordinates to my normal cosine graph, and now I'll distribute in -4 to these y values and get -4, 0, 4, 0, and -4. Now, before I can move on to the frequency, the f in my half pi, I have to now address this +3 to my cosine function. We haven't seen this yet, but you will see this in various problems. And transformation-wise, remember that when you add or subtract something from your function, that causes a vertical shift up or down in your graph. And so we now have to adjust for this. And because it causes a vertical shift up or down, what I'm going to do is, to these y values I have here, I'm going to add 3 to each one of these y values to get the actual y values that will be on this function's graph. So adding 3 to each of these y values, I would get -4 plus 3, which is -1, 0 plus 3, which is 3, 4 plus 3, which is 7, 0 plus 3, which is 3, and -4 plus 3, which is -1. And now, these are the y values I'm going to use to graph out this function, and I'll now scale my axes accordingly. So the lowest y value I have here is at -1, so down here that will be -1, this being our x-axis. And then from there, scaling just by 1, that's going to be at 3, and then this will be at 7. So now I have my y-axis scaled, and so now I can continue on with my half-pi acronym to know exactly how to scale my x-axis. So my frequency in this problem is still the number attached to the x, which is 2. The period of this particular function is just 2 pi divided by my frequency, which reduces and simplifies down to just pi. And the interval upon which I will break up the x-axis will be our period of pi divided by 4. And so this here, again, is exactly how I scale my x-axis. So now I'll do that next. So, and I'll go every 2 markers. So at this marker here, out from the origin, I'm going to label that angle as pi/4. And then pi/4 radians after pi/4 would give us 2 pi/4. Pi/4 radians after 2 pi/4 would give us 3 pi/4. And then pi over 4 radians out from 3 pi over 4 would give us an angle measure of 4 pi over 4. And so now I have both my x and y axes scaled. And so I can now go and take my y coordinates and plot them at each of these angle measures. So starting here on the y axis, my first y value will be at -1. My next y value will be at 3. At my next angle, my y value there should be 7. At my next angle, my y value there should be 3. And at my last angle measure, my y value there should be -1. And then from there, I draw out my graph as best I can, trying to make it a nice smooth curve. And voila, there is the graph to this particular function. So I hope that this video helped you understand how to graph your cosine function. I will make a separate video to do out example number 3 on the lesson plan for today. So if you wanted to see one more of these problems in action, you can. And just remember that Tuesday's homework assignment is due by Wednesday at 11:59 p.m. And Thursdays and Fridays assignment will be a quiz that won't be due until next week on Wednesday. As always, I hope that you guys, take care of yourselves, stay safe, and for those of you celebrating any holidays, I hope that you truly get to enjoy them even in these times. Take care, everyone, and I'll talk to you soon.